All right, today I'm going to be talking about Physics 2212, Lab 1, Measuring Tape Charges, and this is Jackson Perot. Now, to start off with the introduction, the purpose of this lab is to model movement of charges between multiple pieces of tape and calculate the necessary amount of charge required to suspend a piece of tape in the air. So, this lab will entail using a piece of tape with one of the pieces of tape stacked on top of the other to find the necessary charge to suspend tape in the air against the forces of gravity. The fundamental principles discussed in this lab are Coulomb's law, or the equation that will allow you to calculate the electrical charge or electrical force, the law of conservation of charge, which establishes that charge can only move, it can't be destroyed, as well as Newton's third law, which requires that every force has an equal and opposite force. So this first model here, we have a piece of tape hanging from an object. And what we've established is that upon bringing two pieces of tape together, they seem to repel against each other and move away. However, upon bringing a neutral object, such as a book, the piece of tape seems to drift towards it. Then we have if we have a negatively charged pen, if the U-tape is positively charged, then it'll be attracted to the pen. If the U-tape is negatively charged, then it'll be repelled from the pen. And if the U-tape is neutrally charged, then it would be attracted to the pen as well. Therefore, since the U-tape is repelled from the pen, then the sign of the charge must be negative. And over here we have the experiment that we've used for all the calculations. Here we have the initial conditions, including length, mass, distance between the tape, gravity, as well as the electric constant. The assumptions are that each piece of tape has an equal charge, the tape functions as a charge point with all charge concentrated at the center, and that air resistance is to be ignored. Now here we have the calculations, starting on top with the initial conditions, then the force of gravity, which is calculated by multiplying mass by the gravitational constant. Then we have the Q value, or probably the most essential value, as this is the charge that's going to allow the tape to stay up in the air. We have K times Q squared over R squared is equal to that force gravity, which gives us negative 1.2447 times 10 to the negative 8th coulombs. Then we calculate the excess, which is that Q value over 1.6 times 10 to the negative 19th, giving us 7.78 times 10 to the 10th electrons. Then we have the ratio, which is the excess electrons divided by that surface area of the tape, divided by the surface area of the atom, giving us 2.0 times 10 to the negative 7th. Then we have the first part of the code, which establishes all the initial conditions, establishes where the tapes are, or that central charge that we're going to be using as the tape are, as well as the scale factor, and it calculates the vector for force gravity. Then we have all the calculations for the forces that are impacting the tapes, including gravity as well as the electronical force, or the Q value for QA and QB. It also prints the values for the QA and QB and establishes the size of the arrows for the forces. Over here, we have established the key for the red and blue arrow, that essential Q value, as well as calculating the excess, printing the excess, calculating ratio, and printing that respective ratio. Here we have the VPython model with up top with the arrows, blue arrows representing that electrical force, red arrows representing gravity, and then down below we have all of the necessary information that has been printed. Then the systems involved are the Earth, tape A and tape B, and now we have the discussion. So the question was, what if electrons had positive charges and the protons had negative charges? What would be the change in observation? Well, if the electrons, being the mobile charge, had a positive charge, that would mean that the tape, since it is mostly based on the mobile charge, would have a positive charge, causing similar reactions with other pieces of tape as they would push against each other, as those similar reactions to neutral objects. However, with the negatively charged pen, it would be attracted to it, with the reverse true for the positively charged pen. Therefore, the biggest and most fundamental change is that all of the signs on the charges would flip. So, and then we have, why is it important to handle the charged tapes as little as possible? That will less to prevent any interaction with the tapes, and as any form of handling would cause the tape to transfer their charge to whatever they're interacting with, such as your hands. This will give it slightly inaccurate results, as the charge on the tapes would not be the same as they were originally. Then, for the possibility of error, the major possibilities of error in this lab could come from the limitations of slight inaccuracies while measuring due to human error, or due to the handling of tape, as we mentioned earlier, causing a slight transfer of charge. So for this conclusion, In this lab, I've demonstrated that I'm ready to calculate the charge of an object through the use of known constants, as well as force to calculate against Newton's third law. And we have the results for the essential numbers, including that Q number printed below. Thank you.